Good morning, everyone, and thank you very much for joining us for today's webinar, Toronto Community Housing 50 Torbolton Passive House Retrofit Project. My name is Shalika Sivathasan, and I am the Administrative Assistant in the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from today. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and who are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. Kindly note that the chat function has also been deactivated. However, we do highly encourage engagement through our Q&A window, which you will find at the bottom of your screen. Feel free to submit any questions you may have for our speakers there. Questions will be addressed during the designated question and answer period at the end of the presentation. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please allow a few weeks for the processing and reporting of these hours. And lastly, please note that the presenters do not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Now, I'm very excited to introduce our two speakers for today's session. Please welcome Kevin Stekzer and Adam Pelissero. Welcome.
Thank you very much. Happy to be here.
Indeed.
I'll share my screen and we'll get going. My name is Kevin Stekzer. I am the founding partner of ENFORM Architects. We're a practice that focuses on low carbon design, and in that capacity, really thrilled to be principal in charge of the design of 50 Torbolton, working in very close collaboration with Toronto Community Housing and Adam. And thank you very much, Adam. If you want to.
Thank you. My name is Adam Pelissero, a design manager for the three eastern regions of Toronto Community Housing Mines. Toronto Community Housing is the second largest social housing provider in North America, the largest in Canada. We have some of the most vulnerable people in the city of Toronto. And we have an extensive portfolio, and we're doing a heck of a lot of capital work to upgrade that capital or that portfolio. And we're happy that Kevin and his team at ENFORM is doing great work at 50 Torbolton. So, Kevin, you want to start off with slides?
Thank you very much.
Thank you.
Here we have a little graphic analyzing the site a little bit. It's in north of Etobicoke. 50 Torbolton is the address. We're very close to Islington, a major arterial road in northwest Toronto. But this site is quite interesting. It's bounded on the north by Long Park. It's a hydro corridor. We can see Barrie Creek runs diagonally across the site. And we're here to tell the story of what we think is, quite a certainly from our perspective, a very interesting little building. 17 units, originally 4-bedroom units, basement 2 stories, double loaded corridor, each unit having kind of a lovely garden access. And this building has, and we're going to describe the kind of context in a bit more depth, but it's now been sort of redesignated within regional floodplain, so no longer really safe for occupancy. The building was abandoned for not abandoned, but sorry, it was vacant for 12 years due to flooding issues. And it would have been very easy just to write this building off, demolish it, make a public park, return the property to the city for other uses. But Adam worked very, very carefully with the regional authority, the municipal authority, the city, the community aid housing agency itself, in order to think differently about how can we return what could be 17 beautiful units to service Ontarians. And so it's the story of that, of not really skirting or somehow avoiding regulations, but actually working transparently and openly with the authorities to develop alternative solutions that actually work best for Toronto. And secondarily, we're going to talk about how Passive House really amplifies the amenity and performance of these units as we bring them back to Torontonians.
Yeah,
So
this site was it was vacant for probably it's been vacant for about 18 years, I think.
oh wow, 18. Okay.
So there's you can see the intersection of Islington and Berry Creek. There was a culvert that was there that was a rather small culvert, and that caused a lot of water to backfill into the building. And that was really the kind of the straw that broke the camel's back to have this building effectively evacuated or decanted, as it were. And so it sat in that condition for a number of years. And maybe you can just
Well, so just really quickly go through the agenda. So Adam's going to talk a little bit about this existing situation, how we formulated a way to rejuvenate the site with the authorities having jurisdiction. We're going to talk a little bit about Passive House, why I think it's very good and advantageous standard, how we applied that standard to 50 Torbolton, and then just because I'm a geek, I love construction, we're going to look at how it rolled out. So we kind of in a cheeky way are sort of defining the existing situation as the situation.
Yeah. I like that term. So you see 50 Torbolton there. So very much a building of its time, built in sometime in the 60s, I believe. And so you can see on the right-hand image there, the tree line is immediately adjacent to Berry Creek. On the one side, you can see there's probably about 9 units actually that border or that look over that creek. On the other side, you can see the overgrown nature of the backyards to the left-hand side there. And then the building is really just an old, made up of old brick, not very good brick.
Concrete brick, yeah, not very high quality, yeah.
Yeah. So not exactly the best condition. Here you can see this is really what the building looked like when I took it over. Oddly enough, I'm going on 8 years at TCH. This is actually my very first project. I got this project in July, second week of July or third week of July in 2018. And this is really what it looked like from the outside. And it was sitting like that for a while. Go ahead. Continue on, Kevin.
This is a very influential image for me because this is the first time I entered the building. So, whatever it looked like on the outside, which okay, well, the minute we entered it, obviously it was no power. And this is Adam walking up very confidently walking down the central corridor with his headlamp. Exclaiming his entrance, yelling, "Hello, I'm here!" Because there was critter infestation and other infestations, and this just I tried to keep my composure, but walking in here, I'm like, wow, this is pretty creepy. It just sort of reminded me of that feeling you have whenever you watch like a scary movie and you see the protagonist look at kind of an intriguing entrance, and you're like, don't go in there, don't go in there, but they go in there anyway. So this is sort of I was having this kind of feeling at the time.
Yeah. Nobody ever said the client was smart for doing this. But yep, there it is. So here's a condition of it. Really, it really is in a state of, you can totally imagine that somebody would have lived here. But obviously, you can see the various conditions. Kevin, I think the top left here, that's the basement, I think, isn't it?
Yeah, these are all, the top row is the basement, yeah.
Yeah. So obviously each unit has a base, or there are 17 units, 9 on the creek side, 8 on the parking lot side. They all have basements in various different levels, but they all have basements, and there's a central spine corridor right in the top middle there, you can see. And so that is really where the water started to get into. The basements on the right-hand side, there's an image of that later. But this is where the water started to come in, obviously up through the basement, and come into there.
I found this interesting. This sort of, there was a service tunnel on either side that I found when we opened it up. We were kind of maybe not shocked, but maybe still a little shocked of, there was some kind of unintended occupancy down there.
Yeah, it saw its fair share of parties, I think, at certain intervals. So did you want to move it? Yeah.
Yeah, just tell me when to advance the slide, Adam.
Yeah. I mean, this is, it definitely was a place that people lived in. And I think these images really just do a great job of showing that in almost a bit of an artful way.
Yeah, it's sort of interesting. There's a little snapshot, right, of a little bit of occupation. So, initially it's quite revolting, but then you start looking at it and it just becomes quite interesting. I just wanted to identify, here's a concrete block turned on its end, and you can see, maybe 8 or 10 inches of it is submerged. I've never, the water would increase and decrease, but it was never dry for the entire time. Like, we started this in 2019, but you can just get an idea of the typical water level here, but it would rise and it would recede.
Yeah. And next image. Here's the thing: is despite that, I think this image does a really good job of showing actually the quality of the wood. This was not the nice thing, if I can say that, about this building, is that it was not ever hermetically sealed. It was definitely a drafty boarded up building, which actually worked in our favor. And so overall, the quality of the wood in the entire building was fantastic.
We saved probably about 90% of all the wood.
Yeah.
Of the structural wood. Yeah.
Take that. Yeah. It was definitely a case of understanding that there are bones there to be saved. And that's what I think we're doing. So next slide. Yeah, here you can totally see the condition of it. You can see that there's Berry Creek flowing there. You can see the central loading of this. You can imagine the central loading spine or the corridor right down the middle of it. 9 units again overlooking the creek side, and then the 8 units overlooking the parking lot side on the south, on drawing south. And then this was. Can you put the next slide? Yeah, there you go. That's really your 100-year flood line. Which pretty much runs directly down the middle or the spine of the building. And that was really the line that defined the extent of development, as well as anybody knows that has had to deal with TRCA knows that that's a pretty substantial, or that's a pretty important line. And then so anything south of the line is effectively new or something that could be developable. Anything north of the line is verboten. And so, of course, you can see that half of our building is verboten, and the other half is usable. So what we did is, first, right off the bat, is we sailed into the wind, as it were. We went directly to the TRCA. We got the best floodplain engineer that we could find that has had a good, really great relationship with the TRCA. And we had excellent negotiations with them. I think that TCH was able to trade on its reputation as a landlord that wants to do right by the community, and that wants to have a net benefit. And is there for the long haul. And I think that's really something that worked in our favor. You can see briefly in the image that there is actually a little bit of, kind of right in the middle, that there was an egress or a small decks that are permitted. You can see that later on in the deck or in the presentation. And that was actually a real benefit for us as a matter of egress. But you can see here with the watermark that the main concession that we had to make with the TRCA was that we had to abandon effectively the basements. So we pretty much backfilled those basements, locked them off to make sure that people wouldn't be able to get in there and be trapped in the event of a 100-year flood line. So, okay.
Right. So I think what was significant about that is really connecting with the TRCA and then extracting out from them. Well, okay, we understand that the building is in the floodplain, but what are your concerns with respect to that? Okay, their concerns were safety of occupants. So if somebody was trapped in that basement and there was a surge, what would happen? Okay, well, can we make the building safe with respect to that? So again, extracting those requirements and then satisfying those requirements. We're gonna talk about that a little bit later. But I think that was quite interesting. It wasn't just a blanket, well, I'm sorry, the building's in the floodplain, we gotta either, abandon it or demolish it. But there was other solutions at hand. And one of the solutions that was brought to the table was Passive House. How can Passive House amplify the end outcome for Toronto community housing? So Passive House, I want to talk a little bit about the standard. Perhaps the world's most stringent and energy standard, extremely rigorous, proven by thousands of certifications across the globe. You can see in this thermograph here which one is the Passive House Retrofit. The idea of Passive House is that there's lots of heat in and around buildings, and if we preserve that heat, if we conserve that heat through passive measures, we can improve comfort, improve efficiency, improve durability. So for Toronto Community Housing, their mandate is to provide comfortable, resilient, safe homes, and if we can deliver them at high energy efficiency, we're going to have low utility costs. So the Passive House standard delivers more comfort because it measures the mean radiant temperature. It makes sure that all the surfaces inside the building are warm and people are more comfortable. There's no drafts. It's more efficient. There's going to be far less utility costs. We're going to talk about that a little bit later when we show you the energy simulation. It's more resilient. So because the building relies on passive assemblies, if there's power outages, that building will stay warm a lot longer. We actually plot a 2-week zero HVAC temperature drop across the building, and the building remains very, very safe even after 2 weeks without power. And then more safety, because we're controlling airflow across our enclosure, because we're keeping the structure of the building warm, we have higher indoor air quality, less chance of mold. So all these things knit together with the TCH mandate, and so Passive House adds a lot of value. I want to start with a quote here from Dr. Feist, who's the founder of Passive House. And I'll paraphrase him here, but he's saying that even though we're focusing on passive measures and designing an extremely effective thermal enclosure that's very, very airtight and very durable, we're stabilizing the interior environment. And by doing that, if you can keep your occupants comfortable just with a ventilator, and you don't need a typical furnace, that's a functional definition of a Passive House. So really, despite the name, it's really actually this very sophisticated, nuanced, an elegant balance between very powerful passive measures and very low-powered, highly efficient mechanical and active measures. I just want to identify a couple of the resources that I'm relying on in this presentation that I think are very, very good and helpful. The British Research Establishment has their Passive House Primer Designer's Guide, which is great and very graphical. You can go directly to Passive House Canada and get from the Passive House Institute their Passive House guide as well. And so I'm taking information from both those resources. Passive House has it's a certification system, like, for example, LEED. It does distinguish itself from LEED in a couple different ways. But on the left here, we have Passive House Classic. That would be for a new build. So there's requirements for certifying a new build, but Passive House also understands that the same process that we're going to go through to design a new build, we can apply to retrofits very, very effectively. So we're going to focus on the EnerPHit standard. Here are the requirements for Passive House, new build and retrofit. And what I find interesting here is that it's very simple. I'm not saying it's easy to do. I'm saying it's very readily doable. It's not easy, but in contradistinction to LEED, for example, which might have, say, 110 criteria that you evaluate to determine the positive impacts of your design, here we have essentially 4 requirements. We have an energy requirement, a total energy use requirement. We might call that the EY, which is the primary energy demand. It's the same for new builds and retrofits, 120 kilowatt hours per square meter. Now we have what's important, and I think the key concept in Passive House, which is the space heating demand. We call that the TEDI, the thermal energy demand intensity. This is the maximum amount of heat you can put into your Passive House. If you don't manage it properly, you're going to be uncomfortable. It's the same for heating and cooling. Passive House understands that in order to establish this very nuanced balance between powerful passive measures and very low-powered active measures, they limit the power of the system to 10 watts a meter. That's very, very important. And then finally, it understands the air tightness is absolutely critical for durability, safety, and energy efficiency. So A new build has an air tightness requirement of 0.6 air changes per hour. EnerPHit, they relieve it a little bit. It's 1 air change per hour. But we could maybe compare that to like a code compliant building might, or a typical building. I wouldn't say code compliant, but a typical air tightness might be maybe 4 air changes per hour. So it's very, very stringent. So how do we do that? Passivhaus says, okay, we'll put a very consistent, very effective thermal enclosure, thermal blanket around your building. Conserve the heat. And by doing that, we can very substantially keep occupants comfortable. Let's just dive into that a little bit. This pie chart here is for a high efficiency MERB in Canada. It's showing us the end use breakdowns to the various energy. So the whole pie is the total energy use intensity. It includes things like lighting for all those night owls out there. You need lighting at night. Plug loads, this would be for charging your iPhone or keeping my Prosecco chilled in the refrigerator. Domestic hot water is a big one for MERBs, for multi-residential buildings, hot showers and washing our clothes. But you can see that the brown slice there is the heating. That's the thermal energy demand intensity. So it's the portion of the whole thing. So it's a subset. But we can see that this is the heat you have to replace to keep the building comfortable. And where does the heat go? It goes out our windows, through our walls. We have to ventilate the building to keep it comfortable and safe. So we have to heat and cool that air. So that's a loss. And then no building is 100% airtight, even though passive house buildings are extremely airtight. So we lose a little bit through infiltration. Let's look at it a little bit differently. You can see the losses on the top, and then window, wall, ventilation, infiltration. So that's the total demand. So your furnace, if you were to have one, has to replace that. But wait a minute, passive house tells us, okay, there's lots of heat associated with buildings, lots. If we put in a very good energy recovery ventilator, I'm going to show you how we do it in a few slides, we can recover the majority of those ventilation losses, right? People generate heat. Even our most efficient LED lights generate a bit of heat. Equipment generates heat. Refrigerators dump heat into the kitchen, for example. And then also passive house tells us that if we design our windows properly, we can actually, in certain cases, deliver more heat in the building than we lose. So there's solar gains. But we can see that it actually doesn't meet all the losses. It starts to approach the loss. So the final little block there, the heating output, is the thermal energy demand intensity. That's the amount of heat that we have to put back into the building to meet the losses. And passive house limits that. For EnerPHit, it limits it to 25. Now, I want to put that in context. The typical MERB in Canada right now might use maybe 240 kilowatt hours per square meter per year. That's the total energy use intensity. And roughly 50% of that is for heating. So 120 is roughly the TEDI. So that's the typical building measured data that we have. Passive House asks us on a retrofit to reduce it to 25. That might sound ambitious, but it's proven. Thousands of EnerPHits have been certified across the globe. And again, this balance is very important to the concept of passive house. So we look at the losses and we look at the gains, and we try as much as we possibly can to balance them. And by putting in those small mechanical systems, we start satisfying that functional definition of passive house. Now, how do we enact the low TEDI approach? Again, we can look at the standard and it gives us guidance. Let's just go around this graphic here, this section through an idealized house. Superlative insulation, very, very important. In a cold climate, that's going to be quite a bit. We put in the highest quality windows we can afford. If we're doing a passive house, we use passive house certified glazing. Passive house has a very stringent way of simulating the effective performance of the windows. That's why we use pre-certified products. I'm going to skip ventilation for a sec and move to air tightness. Passive house buildings are very, very airtight. The standard understands that if you allow uncontrolled air across your enclosure, well, you're losing lots of energy. You've spent a lot of energy heating and humidifying that air. Why let it randomly evacuate your building? But there's another component there that's very, very important. It's also safety. If we allow air to mass transport moisture across our enclosures, we can deposit a lot of that moisture in our assemblies. Well, that's dangerous. With respect to wood, that can cause mold. With respect to light gauge steel, that can cause corrosion. So there's a safety issue there. So it's both efficiency and safety. Now, finally, thermal bridge-free design. This is very, very important, and passive house understands and teaches us that a building that doesn't consider the connections of all its components, it can lose up to 50% of the heat that furnace puts into the building. So because it's concerned with thermal demand, we mitigate the heat that leaves through the seams. So windows to walls, walls to roofs, walls to foundations. We look very carefully at the heat flow through those connections, and we prevent it. We design it to mitigate that heat flow, and then your furnace doesn't have to replace that, so you can downsize the furnace. And again, establish that functional definition. Now, when we look at the thermal blanket, Passive House pre-certifies lots of wall assemblies for us, and it says that in a cold climate, you probably need a U value of 0.15. What does that mean? In our value, that's approximately an effective R43. Wow, that's pretty significant. It says that when you're designing your shading, use the highest quality glazing you can, Passive House certified products, but also look at your orientation. Understand that there's heat out there, the sun can deliver it, so you look at your orientation and you design your glazing very carefully to help improve the thermal demand. Because it's very, very worried about where heat goes, heat wants to leave through the seams. So when we knit our windows to walls together, it gives us guidance. We can look into Passive House, and it encourages us to over insulate the frame of our windows because it understands that most of the heat flows through the frames. It also understands that thermal gain, solar gain in the winter might be very good for us, very beneficial, but in the summer, not so much. So we look very carefully at passive means to shade our windows, and that's part of the standard as well. Thermal bridge-free design. Again, Passive House teaches us that up to 50%, sometimes even a little more of our heat that we put in our buildings can leave through seams. So let's look very carefully at those seams. Passive House defines what a thermal bridge-free. It's a very rigorous, stringent standard. Less than 0.1 watts per meter is allowable. If we have heat that leaves through connections that transfer more than that, we have to build that into our energy model. We have to build that into our thermal demand. So it's encouraging us to conserve heat in a very careful way. There's an efficiency side of that, but Passive House also wants us to consider the indoor temperature. Where we have thermal bridges, we have accelerations of heat flow. That means we cool the interior surface of our building, which is unwanted. This graphic is from Passive House, so you don't have to understand the math. But what it's saying is that even corners conduct more heat than perpendicular through our walls. And that's not to say that we don't design buildings with lots of corners. It's to say that we have to take that into consideration in our thermal demand. So here, this is telling us that a thermal bridge is a weak point in our thermal enclosure. We have to account for it. If we're conducting more heat through those points, the indoor temperature reduces. And therefore, we start to subject the interior of the building to a wide range of radiant temperature. And Passive House has a requirement for the mean radiant temperature to be within 4 degrees. This is important because then our body registers very little the difference in various temperatures and feels comfortable. And therefore, we can actually design the indoor air temperature to 20 degrees, not 21 or 22, because Passive House understands that it's actually the consistency of the interior temperature that's more important than the actual air temperature itself. Air tightness. Air tightness, again, extremely important. We've talked about why it's inefficient to let air randomly flow across our enclosure, but also it's dangerous, especially as we design very, very powerful thermal enclosures. We can really, if we let vapor migrate through those assemblies, we can get condensation, and we don't want to trap moisture. So for both of these reasons, and for comfort reasons too, we don't want drafts. So Passive House asks us to prove through whole building air tightness a minimum requirement, and this is a very, very important. It also gives us little tools, like as we're drawing our assemblies, it asks us to draw a continuous uninterrupted air tightness line throughout our building. And this is actually a great tool whenever we're drawing building enclosures, but it's when we submit for Passive House design certification, we actually have to draw that line and show that it's continuous and uninterrupted. Now, finally, ventilation. Now, Passive House understands that now that we have this beautiful, stabilized interior environment, we have to keep the indoor air quality very, very high. So it says you need a very, very efficient energy recovery ventilator to re-oxygenate the air, relieve stale air. But it tells us how to do it to a level of efficiency that's very, very effective. They're not just asking us to put a very efficient fan in the building. we have to put a very efficient fan in the building, and we have to measure all the static pressure losses of all the ductwork. It's really a whole system recovery. It's quite rigorous. So, how do we do it? It encourages us to actually put in a very high efficiency heat energy recovery air handling unit. But what it tries to encourage us to do is use the house as a distribution path. So we avoid ductwork. Ductwork imposes friction on airflow. It increases the static pressure. We have to use more powerful fans, so on and so forth. So it actually helps us design our buildings so that we can reduce that energy load. And this is how we typically do it. This is a graphic of what we might consider like a typical energy recovery ventilator. So in heating mode in the winter, we're taking hot, humid air from the inside. It's stale. We don't want it anymore. So we have a fan that depressurizes the house. It moves that airflow out to the exterior, but it runs it through what we call an energy recovery core. That core is made of very conductive metal like aluminum, and it's coated with like a chalk desiccant. So it warms up as the hot air runs through it, but it also absorbs the grains of moisture. And then we have another fan bringing fresh air in, which is cold and dry in the winter, and we run it through in cross direction through that energy recovery core. It heats up because the core is hot, and then it takes the moisture from the core into the incoming stream. And so these units can get up to 90% energy recovery, enthalpy energy recovery. That's the combination of moisture and temperature. So these fans can be very, very efficient, and that's typically how we do it. So just to wrap up, the standard as it applies to renovations, it's kind of a cheeky name, EnerPHit, PHIT. But anyway, the EnerPHit requirements are the TEDI limit, the thermal demand limit, 25 kilowatt hours per square meter. We have to be that or lower. The primary demand, the total energy use intensity, 120. Air tightness limit of 1 air change per hour. And then, of course, understanding that functional definition of a passive house is really using very small mechanical systems to keep your people and your occupants comfortable. We have a system power limitation of 10 watts a meter. So that sort of wraps up our talk on passive house. I'm just wondering, Shalika, if maybe we could do we have a little quiz for our visitors? Here we go. Okay, so we're going to have 3 questions for you. So what is the TEDI? Second question is, what is the air tightness requirement for EnerPHit? And then I think number 3, why is air tightness important? I think it's just cut off there a little bit. We might have to expand it. And Shalika, you let me know when we can talk about the results. Okay, it looks like most people got it right. It's the thermal energy demand intensity. The reason why I asked this question is that the TEDI, as we call it, it's a subcomponent of the total energy use intensity, and it's becoming a very, very important metric. Passive House invented it, but it's becoming a very important metric for all certifications or lots of emerging certification systems. So, for example, Toronto Green Standard asks you to report the TEDI of your design for compliance. The Zero Carbon Standard also asks you to design to a TEDI limit. So it's becoming a very, very important way for us to actually evaluate building design, because it actually gives us an indication of how passive is the design. So this is why it's important. Okay, what's the next one here? What's the air tightness requirement for EnerPHit? And I can't see all of the answers. Oh, I can scroll down here. Let me see. So yeah, almost everybody got it right. 1 air change per hour. The 0.6 air change per hour is for new build. Again, air tightness is super important, and most people got it right. What I wanted to encourage everybody to think about was that when we make buildings airtight, we're preventing energy loss. We're also improving safety, because we're not allowing moisture to cause mold or corrosion in our assemblies. We're improving comfort because there's less drafts, and we're keeping that mean rating temperature, and we're stabilizing the interior environment. So the answer in my mind was all of the above. applies to air tightness. So thanks for that. Is that okay, Shalika? We can move on? Okay, so so what we wanted to do now was look at how did we apply Passive House to 50 Torbolton. Now, Passive House, as a part of this presentation is ultra important, but it really it fits within the matrix of concerns that us as designers and kind of curators of the physical urban environment. It's one of the factors. We still have to thrill our occupants. We still have to create beautiful cities. And as we were looking at this property, there was something very beguiling about the building, its basic geometry. It was quite simple ostensibly, but a few different moves kind of gave it some complexities. But nonetheless, it had this relationship to some natural elements. And so, without overstating it, we started looking a little bit at also like some of the kind of basic forms and neutral palettes. We definitely wanted to relate to landscaping in a simple, clear, but a sort of charming way. So these are some of the kind of precedents and inspirations that we're looking at. We looked at, do we decentralize the mechanical systems? How do we reveal the latent amenity of the project, right? So we started modeling it and looking at, okay, let's just, let's not, again, great skeleton of the project. How do we just, give it that new thermal enclosure because it's going to be quite deep? Could we maybe emphasize the returns with, various motifs of color and texture and amplify the thing in a very, very simple way? This is looking at the lakeside. So we were mandated to raise the building up and bring out these safe areas of refuge decks, but how can they contribute to the overall design in a simple way? We wanted a very elegant neutral palette, but again, looking at the plan here, really just bringing it back. The units had a wonderful proportion. We're going to show you we decommissioned the basements, but the ground floors had the kind of living, dining, and kitchen spaces and the entrance areas. You would move upstairs to the bedrooms and the washrooms. Really, really lovely proportion. Exposing both to the creek side and to the parking lot side, these garden areas. So how do we really just amplify that? Again, revealing the what was already there, being sensitive to it. Here's a view of the garden units. Again, very simple treatments. Careful, linear, but just the slightest little accents. So as we applied the EnerPHit standard to the building, we started drawing up the assemblies. These are some early sketches of our early proposed assemblies. And what this is intended to show is that there was actually a great opportunity with the structural masonry on the exterior, with the concrete block backbone of the building. We could actually develop very consistent lines of air control. And we thought that this was very advantageous. So we ended up selecting, we looked at rain screen mineral wool, we looked at mineral wool EFIS, we looked at XPS EFIS. We actually landed upon graphite polystyrene rear drained EFIS for the system, both for its thermal effectiveness, cost effectiveness, but also as far as the foam goes, it's much lower carbon. So this gave us a great opportunity to apply very consistently across the enclosure this system. And because it was not occupied, we had the ability to use this product, which has proven very thermally efficient. So we just wanted to do a case study of how we looked at one juncture in the building and tried to apply the principles of Passive House, the low teddy approach. So these are images of the original garden access windows, had these protruding canopies. And, once we started opening up and looking at them, all sorts of stuff was revealed. Like the wood was deteriorating. It was supported by these cantilevered steel channels, and they were bending. They were applying quite a bit of torsion on the lintels, so over top of the windows, and that was dislodging some of the bricks. So we decided that we didn't need those large those canopies, we'd replace them with a much more modest version. So looking at this is a worm's eye axonometric. There's the existing system. So careful demolition. And as we demolished it, we looked at any superficial corrosion or damage, and we repaired it. Where we needed gussets, we welded in some gussets. But ultimately, we wanted this consistent plane where we could apply the new air control and water resistive or weather resistive barrier. So we have this nice plane now where we can put on this air control and water control layer right here. So it's nice and consistent, and we get a very, very careful integration with the new fiberglass triple glazed Passive House certified windows. And then we added the thermal layer, and then a very, very light aluminum brow where we could insert some accent lighting. And here's the final assembly. So it just shows you the process. We're trying to carefully bring it back to the skeleton of the project, and then very simply bring it back. Keep the interior as warm as possible, have that air control plane as consistent as possible, very, very robust, careful connection into the window assembly, and then final trims. So that's the passive approach primarily. We'll keep talking about it. But again, going back to, the building still needs ventilation and a little bit of heating and cooling in peak demand, usually, end of January, February. So we looked at decentralized systems. We looked at centralized systems. We ended up going with a centralized energy recovery ventilator, DOAS system, which is dedicated outdoor air. And what that means is it's just delivering the volume of air that's required for ventilation. We're not heating and cooling the building with this unit. So we're just delivering extremely high indoor air quality from this energy recovery ventilator that's demand operated, meaning it has its own control sequence. So it delivers, and I'll show you some of the ductwork in a little bit, it delivers air to each unit with its own react damper that's controlled by this fan, demand operated by this fan. So it's a very, very highly, this fan is Passive House certified. This is a very high quality. And if you're into fans like I am, this kind of stuff excites me. And then we analyzed the building for its thermal demand, and at peak loads, it still needed a little bit of heat. So we put in a air source heat pump, and we put in a VRF air source heat pump. And the reason we did that was that there were times during the year where there was not all the units were in the same mode at the same time. So VRF gives us the ability to do internal heat recovery. We can move heat within the building instead of taking it out of the atmosphere. But also, even if we're in consistent demand, if all the units aren't in heating and if all the units aren't in cooling, the VRF unit can turn off those circuits of refrigerant and lower the load on the compressor. So we got a lot of efficiency from the system. But one thing I just want to add to this is that we were very concerned about dehumidification. We wanted to make sure that we could keep the air dry in the summer, and the VRF system gives us that power to be able to dehumidify in the summer. And I just wanted to show how we used the central corridor to deliver the central air. And then we tried to be very careful to use the already existing light framing to deliver the decentralized heating and cooling. So the ventilation is centralized, operates on its own demand controls, and the heating and cooling is separate. They just operate according to the unit's thermostat. But what we did here that I think is quite unique, and you can see perhaps maybe in these sections here, which go through the center of the building, that central double loaded corridor, is that we put fire rated access hatches to the fan coil units right at the corridor. So the idea is that Toronto Community Housing can operate and repair and manage these units without entering the unit and disturbing the occupants. And I think this is quite innovative. But these are also drawings to show that we're very, as anybody would be, we're very concerned about integrating these new elements efficiently into the existing. So we tried to lay out all the framing so we could use those cavities to distribute our surfaces. So this is the energy simulation of the project. So what we're seeing here is that the building is roughly 20,000 square feet. The TEDI limitation is 25. We're in and around 24 right now. We're right there. An overall energy use intensity of 65, which is quite low if you consider the typical MERB. Like when we did the baseline for this building, the baseline was, I think, over 300 EUI. So substantial reduction in energy consumption. But we worked with our engineers at Morrison Hershfield, now Stantec, to develop what we called an energy performance map. So this is important because what we did was we modeled many thousands of iterations of energy cycles. You can see all the energy simulation outputs over here with interlaced between various enclosure performances and various mechanical systems. And the reason we're doing this is because I'm a big believer in Passive House, and I'm a big believer in the value that it brings to this property and many others, especially for Toronto community housing. And we wanted to optimize the amount of insulation that we put in that building. We wanted to optimize the system's performance so that it became affordable. So we modeled this against code compliant building. Yes, we did need more insulation with respect to Passive House, but not that much more, because we modeled all the inputs and outputs, and then we picked the path that had the least enclosure performance for the maximum output. So this is how I think this is a tool we can use to really amplify our design efforts to get these high performance standards in place at affordable price. So here's a section to the building. The creek side's on the left, the parking side is on the right. And what we can see here is that as we looked at the TRSA requirements, the first thing we needed to do was make that basement safe. So we actually backfilled the basement with aggregate, free draining, crushed stone. Now, I found this is quite innovative in that we spent a lot of time in this building. So we actually did the procurement of the construction in 2 phases. We did a whole building demolition phase first, stripped the building away, and then dived even further into it to examine all the what was left over. And we couldn't find operating drainage systems. There was some in place, but they were connected, or they were broken, or they were overwhelmed, or they were infested, or whatever the case might be. But that building wasn't draining, and we couldn't get an affordable drainage system in there that would be reliable, in our opinion, to keep that basement dry, especially in a flood scenario. So Adam had this idea. Well, why don't we just fill it with gabion baskets? Stabilize the environment. We'll drop the humidity down into the aggregate. And we thought that this was a really, really robust and remarkable solution. So we tested it out, and so that's what we've done. We've filled the basement with aggregate, basically treating it like a foundation. And that has a dual benefit of allowing water ingress and egress without any impact to the human occupation. It keeps people, decommissions the basement, keeps people out of it, and we get and it dries out. It dries out the basement too. It wicks the moisture down into the aggregate. So we thought that this was a great solution. We apply the low teddy approach, the new thermal enclosure, all the way around the building, and then finally, here's the 100-year floodplain. And what we did was we actually reinforced with a concrete upstand. We brought the building up to this 100-year floodplain so that if ever there was a flood, occupants could evacuate the building, keep the water out at that level, and then they could use this deck as an area of refuge, a safe area of refuge. So we actually designed these decks with helical foundations so that they could actually withstand both the surge of the flood and the recession of the flood. So very often when a flood happens, it creates a lot of debris, and then when it recedes, all that debris comes back with it. So these decks have to be robust enough to withstand that. So that's how we satisfied the TRSA requirements. So you can just see here, this is an axonometric looking down on where we define, or where TRSA defined that new floodplain. And so there's the floor, and we built up these curbs that line. And so we had these little millwork steps that brought us up to that safe point. Here are a couple views looking at it. I should point out that TCH actually put 40 kilowatts of PVs on the roof. So this project is actually now poised to apply for zero carbon certification as well. The Passive House energy fulfillment or compliance means that the energy requirements are low enough that they can satisfy the zero carbon standard. And now with the ability to clean out the carbon of the operational energy, that certification is poised for that certification as well. And here are just a couple images, again, just trying to be sensitive to the existing blocking and stacking of the building, and just, in a very subtle way, just bring it back to life with some subtle landscaping and that neutral palette of materials. And again, just kind of summarizing, Passive House working in conjunction with those TRCA safety requirements, help the building protect against that floodplain, allowing the building to be rejuvenated. It's stabilized against the higher water table, so there was this kind of synergy with the flood protection, right? We used a Passive House to amplify and I'm using that word a lot this presentation, amplify, but we increased the value of the property, making it more resilient, more comfortable, lower utility costs. And because of that, the amenity of the original design is now released, and we returned 17 kind of lovely family units to Toronto. And just sort of to summarize and kind of finish up, we thought we would show some images of the construction because, of course, I love construction. We love construction. So we just thought we would kind of run through we're about 2 months away from substantial performance, so we're nearly done. But here are some images of when we first visited the property. The first phase was demolition, and just after demolition, we then procured the full retrofit. But this slide for me is interesting in that most of the wood was very dry and wonderful to reuse, which is great. But there was one unit, and one unit alone, where for whatever reason the flooring was vinyl. And why this is important, we discovered, is that the vinyl is vapor impermeable. So as the basement was flooding, all the other units that had wood floor, the vapor was allowed to diffuse out of the basement into the building outside, wherever it wanted to go. But in this unit, it couldn't. And so the vapor saturated the wood. And as the constructors were in there demolishing and fixing up, the floor slowly collapsed. And we discovered it was because of this was the only unit that this happened. And it was because of the vinyl. It reinforces the fact to me that we always have to be careful of the vapor profile of all of our envelope assemblies. But anyway, the floor was replaced very readily, and you can see down here in the basement they used that hole as an opportunity to actually dump in the aggregate. So they started dumping in the aggregate. You can see the floodwaters are now being overfilled with the aggregate. So I thought that was an interesting slide. Here you can see the central corridor. Just again, after demolition, we brought everything back to the bones, the skeleton of the building. Again, very, very robust structure. We're testing out some of the central ventilation ductwork up suspended from the ceiling there. Down below, you can see the new, we used the basement for electrical runs and plumbing runs. We can see here the replacement of some of the floor joists. Looking at various construction images. This is actually looking through one of those portals we put in the corridor wall to access the fan coils. So this rated door could be opened, and then the Toronto Community Housing operators can go in there and operate the equipment without necessarily entering the units. Here are some before and after. I think are, having worked on the project with Adam for quite a long time, it's really satisfying to see. There was, you can see the couch here. There was some kind of unintended occupancy going on here, kind of interesting. But nonetheless, we can see on the right the where we're at now. The general contractor, Martin, was very careful with the existing trees. A lot of these trees were tagged by TRCA, so it was a mandate of the project. But nonetheless, you can see the decks. They're on helical piles, so they're very robust. Again, before and after. Again, simple palette, simple colors, really high performance fiberglass triple glazed windows from Inline, beautiful doors. We actually put around the property a below grade French drain, so we could again take all that water that might impact the facade and route it back out away from the facade. Again, before and after, this is kind of intended to be not the rendering but the real view along the creek side. And then all these, again, we're almost done. All these railings were saved, painted, reinstalled, and now we're going to put new wood slats in there so that there's these privacy divisions between the garden suites. And then before and after kitchens, nice warm light. Adam's very careful about lighting quality, and Toronto Community Housing has lighting standards, nice warm light. Here we can see the roof, the existing membrane. We replaced it with a new high performance membrane, and now we've just completed 40 kilowatt PV array for clean energy generation. Now you can see the basement. We've filled it up with aggregate. You can see at the top here the foam below our first floor. This is actually a fire retardant foam on top of the thermal foam. So this is the thermal barrier, the safety barrier, the ignition barrier, I should say. And now these are some water infiltration tests and air tightness tests that we're performing on the enclosure. We're doing some guarded assemblies to test the assemblies prior to do a whole building air tightness. They're coming back quite positive. We're doing some thermographs to look at any potential holes. So we're just on the cusp of doing the whole building air tightness tests. And this is just a summary where, again, if for those who are interested, 17 units that were basically written off, and Adam said, I think we could do something differently here, worked with the authorities to generate innovative solutions, said what's the greatest value we can do here, determined it was affordable to do a passive house, and we're really, really excited to open it up just in a few months. I don't know, Adam, if you wanted any closing words.
Yeah, I mean, we're really happy with how TCH is really happy with how this project is proceeding. We see it as resiliency. I'm glad that you used that word a number of times because that's such an important word to us. And being able to make sure that that we can build places that are going to be able to last. And that are going to be able to serve the community, to serve the tenants, to serve the city as a whole, and to make sure that we can do it in a way that is responsible, and again, responsible in the national interest, to make sure that we TCHC gets two main streams of funding, obviously from the city, but also from CMHC. One of the mandates that we have from CMHC is that we drive down or that we advance energy efficiency and drive down greenhouse gas emissions. And so being able to do that in the national interest, being able to serve the community's interest, to actually give real homes to people that need them, and actually being able to maximize the value of this property is a really great thing. And then also being able to use a lot of the lessons that we learned at 50 Torbolton across some of our other projects, and across our other projects in our other along the portfolio. As it relates to air tightness, you can't fake air tightness. Either air gets out or it doesn't. And so that's a very nice metric to be able to at least adjudicate some sort of quality, and to be able to implement that type of metric into our contract documents. We're trying to make sure that we're building better, more resilient buildings, not just at 50 Torbolton, but trying to use this is a case study for our other projects. Anyway, I don't want to take up too much time. I mean, that's pretty much an hour right there. But yeah, no,
well
Kevin,
said.
It's been fantastic working with you and the team at ENFORM to move this forward. And I know everybody here is excited to be able to open this up and give 17 families a home. So
thanks for that. Okay, Shalika, I think that's the end of the formal presentation. I mean, we're obviously thrilled to take questions if we can answer them, but yeah, there you have it.
Absolutely. Yeah. So there's already some questions in the Q&A box, which is great. Again, we encourage all attendees to submit your questions for Kevin and Adam. I just want to begin by thanking you both for a really excellent presentation. The photos at the end were especially really beautiful, and it's great to see the work that you're doing at 50 Torbolton. So it's been a great presentation. So we have quite a few questions in the Q&A box here. So I'll read the first one out. This one is from Gregory Rubin, and it says, when you say lower carbon on the foam, what is its overall contribution to the project's carbon footprint? Do you have stats to compare that to other systems?
We do. And if it's, and Gregory, I know you, we're friends, so I can send you. We did do an analysis of the embodied carbon of the enclosure system. So I think any decision that we make is a fairly the calculus is fairly intensive and maybe sometimes a bit complex. I would say we would certainly now moving forward avoid foams. But of the foams, it was the lowest that we could apply, and given the thermal slash cost slash carbon impact, we felt it was the best. So I would be happy to share an email with our comparison on that. Yeah, we are our total embodied carbon intensity for this project is just south of 65, I think. Something like that. I'd have to pull up we did do an LCA for it. I hope that answers Greg's question.
Great. Thanks so much. So we have another question here from an anonymous attendee that says, as an owner and developer standpoint, what is the rough idea in terms of costing for a passive house? Will it increase the construction cost by, say, 15 to 20%, for example?
Right. There's two sides to that. Kevin, did you want to take a crack at the direct cost? Because we come at it from a bit of a different metric. Go ahead first.
Sure. Well, our analysis was between 4 and 5% between a code compliant installation and an optimized passive house, which we think this was the case. So passive house, you can do a prescriptive application, or you can do a whole building simulation where you prove your thermal demand meets the requirements, and that's what we did, and that's why we got to that between 4 and 5% premium. Yeah, so I don't know if
Yeah, I think at least from our pro forma, there is that cost, but also as a condition of Toronto Community Housing's funding arrangement from the CMHC, there is a carbon reduction a stipulation, and so that was sat outside of the monetary incentive and really actually went to our funding incentives. So slightly different pro forma than a strict than a standard owner, standard developer, I'd say.
Yes, of course. Yeah. The windows are expensive. That's what we're finding now. We're getting more and more products on the market, but I would say currently that would be from a purely capital investment perspective, we feel that currently is the largest contributor to the premium for the pre-certified windows.
Great. So we have another question here. How close is the building from the hydro corridor? Were the EMF studies done? Were there any concerns on how it might affect the health of the occupants?
We're probably about well, the neighbors are closer to the high voltage lines. So yeah, and electromagnetic study wasn't performed, but the two neighbors to the west are closer to the corridor than we are. But we're about 100 meters from a pylon at the closest point.
Yeah.
But no, we didn't do a study. We didn't we didn't consider that. I'm sorry.
Yeah, no. For us, it was really there was only one option really with two results: either save the building or turn the building into a park. That was pretty much about it. So I think that we made the right decision going from there.
Great, thank you. So we have another question here. We've seen passive house requirements being applied to larger projects. Do you see the need for passive house being applied to single family home or even the newly suggested multiplex and sixplex? Will it have less value compared to larger projects?
All of these are very important questions. And one thing maybe to answer that, if I might, is that passive house has various tiers. So we elected to go with the highest tier. And for the highest resilience, for the highest energy efficiency, so on and so forth. You can do several tiers, like there's what's called passive house low energy building standard you can apply to, which isn't quite as stringent as the classic that we are going for. The reason I say that is that I think all projects can benefit from the low TIDI approach, right? And I would say that we've discovered larger buildings have more internal heat. So when we do the energy simulation approach to certification, we're seeing slimmer enclosures. because there's more internal heat. The smaller the building, the less occupants, the less internal heat, the more enclosure to area ratio there is. That's why the assemblies tend to be so thick. So I would say that looking at a carbon and cost indexed view, I would look at the occupancy of the building against what the return is, which you want is low carbon, but you can achieve low carbon in a variety of ways. Like this project is also exploring on-site renewables. So Passive House now is introducing standards where those requirements are adjusted with on-site renewables. So things are evolving, and I know that I'm orbiting the question. The point, I think larger buildings, it's actually easier to do Passive House certification, right? Smaller buildings are the hardest. Single family homes require the most performance, per unit area of occupation. That you have the smallest occupants, the least number of occupants. So I would say that there could be other Passive House standards, or I love the zero carbon standard. You could use that to balance out what you're trying to get. What we want is in my opinion, the most comfortable, most resilient, highest value asset in the end. And in all cases, that means, low energy intensity, but it also, I think, means low carbon intensity. So building out of low carbon materials, but also using clean fuel. So, I don't want to be religious about, and I'm not religious about certification systems. I think certification systems in every case help owners and operators show value. Now, which one you pick, I think that would, you could discuss quite intensely. So I would say that there's variations of the Passive House standard you could use, or you could look at the value of Passive House in big buildings because it actually gets a little easier. I know it was a long answer, and I apologize. I hope it helps.
Very, very thorough. Yeah. I hope that answers your question. We have another question from Annabelle Vaughn, who asks, you've spoken about the natural moisture of the site being able to escape as one of the things that saved the bones of the building. The creek moisture is still going to rise up in the building. How is it being dealt with?
Shall I, Adam?
Yeah, absolutely.
Yeah.
Absolutely.
So basically, we're kind of saying that the basement now is like a foundation, so it's not occupied. And similar, let's say we were to drive footings down there, and then the water table might rise or lower. It's not the concrete footings were very water tolerant. The building hasn't settled according to our measurements. So the water, over the lifespan of the building has risen. The water table has risen and lowered continuously. So we're kind of saying that that's going to continue, but as we pile up all of this aggregate, we have a regime in there, maybe 1/3 of the volume that can absorb or release vapor. And the idea is that we're not allowing people in there now. So whereas before you had interconnection, so it was a dangerous zone. We had to decommission it. So that was the first level, was decommission it and just allow the water in and out. It's still happening as you intelligently identify, but now we're not exposing occupants to that danger. And then that top surface of aggregate, like, for example, the wonderful cuvées, the caves of France, putting their wine in there. They wanted they want the moisture to lower down into that aggregate. And so we're drying out that regime right below the floor a little bit. So I guess we're just saying is we're turning the basements back into foundations where we're not as concerned about that ongoing water ingress and egress. And again,
a little bit of luck works too, because fortunately the city also did expand the size of the culvert that is immediately adjacent. So I think that is going to really, or we've already seen it work its magic by having Berry Creek naturally drain past at least where 50 Torbolton was located,
just lower that water table,
go past under Islington. That means that it's hopefully not going to be backing up into 50 Torbolton. And we did notice that as soon as that work was done, we did notice less water ingress, less times the water table actually reached up over the boots.
And I mean, going there for now, I guess 6 years, you can smell the difference. So the high humidity, reveals the smells more. Now it's very, very dry down there. And we do have a small ventilation system in there to manage potential radon in the future and so on and so forth. So I think we've tried to be conservative about it, but nonetheless, that's the approach.
Great. There's actually a follow-up question from Annabelle as well. So she's asking, is there a barrier between the gravel and the living spaces?
Yes, a very significant barrier. Thank you for, if I didn't make that point, yes, a very significant, like an R50 floor. So we've kept the structural floor, we've replaced the flooring, but underneath we've put in spray foam and a thermal barrier. So it's a very airtight and very thermally efficient. Yeah, very significant sealing of that element, that floor. Yes.
Great. We have a question here from Jeffrey Weatherston who says, what was the process for hiring the building contractor? What was the contractor's experience with this type of work?
Yeah, so we do a lot of hiring at TCHC. Both a lot of vendors get hired at TCHC, and so we obviously do it's a two-stage, or sorry, it's actually a three-stage procurement process. There's certain rectifiables. Then there's a quality assessment, or the proposal side of it that we do review, and then finally the quote. It is weighted. I forget the weighting, but then for this, obviously, this is a size building that doesn't see, or at least when we tendered it, didn't see a lot of similar passive house building types. I think that Kevin, forgive me. Oh, sugar. We had around 7 million and change ish.
Oh, do you mean the tender price?
Yeah,
Yeah, it was 6.7 million was the
thank
tender
you.
price.
$6.7 million. So that price is kind of unique in the industry that we didn't see a lot of. But one of the things that we did do is we took a look at passive house and the requirements of the contractor to fulfill the passive house performance side of it. One of it is obviously the technical considerations on site, but then the other portion of it is the paperwork. The paperwork needs to be in place to be able to actually apply for and get certification. So that audit trail, as it were. So one of the things that we did is we tried to look for something similar to that and say, well, are there certain portions of other high performance buildings like LEED or something like that to say, you can do this. You understand that there are certain sensitivities and certain understandings that you had to implement in your construction process. Can you do it here? It's kind of the idea, but yeah, this is, at $6.7 million. Kevin, you probably know more than I do on this one, but I don't know many passive house buildings at that price point. You're saying maybe larger buildings, but
I mean, I think I think you've mentioned it before, but part of the metrics for evaluating the site was either this or nothing. So, imagine spending money demolishing it, backfilling it, prepping it as a park, and then have no units. So I think we worked together very carefully to try and create the best value we can. TCH has very ambitious budgets, very aggressive budgets. So I do think it's good value because we're also units of this type aren't part of the typical offering, right? The kind of the beautiful proportion 3-bedroom units. So these are family units, all having a garden access. So I do feel it was good value, but also it was okay. Then spend money to make it a park and then give it back. So I think it was good value on many levels.
Yeah, but I think in terms of hiring the contractor, yeah, that was the goal was, is there something that was similar and going from there.
Great. So I think we have maybe 2 more questions in the Q&A box for now. One, I'm not sure if maybe this was already answered or if it's possible to answer, but one question is, what was the cost per square foot for the retrofit?
Very roughly about 335. Yeah.
Okay. Amazing. And then Annabelle has one more follow-up question. So she says, sorry to keep thinking about this. Did you say that the basement is passively ventilated or mechanically ventilated?
Mechanically ventilated. Yeah.
Yeah. Gotcha. Okay, great.
Yeah,
So
which we had to do very carefully because that fit into our thermal demand. So so that was part of the calculation of thermal demand. But it's a very small fan. And when we looked at the overall, just make again, it was also, we thought a little bit about radon. It wasn't a requirement right now, but maybe in the future it would be. So yes, it's mechanically ventilated.
Great. So I think actually Ashley has some questions for you. So there she is. Yep.
Hi. Thank you again for your presentation. It was fantastic.
Thank you.
2 questions for you both. What was the biggest lesson you learned from this project, if you could both answer?
I'm gonna let Adam
Putting you
go
on the
first.
spot.
Well, I mean, for me, I guess engaging very authentically and transparently, and I would say at times arduously, with every level of authority. So at the regional level, I thought our relationship with the TRCA was actually, once they, I think, discovered that we were intent on satisfying their mandates. I mean, keep it safe in a flood, and proving that, and then seeing that through. I think there was a trust factor there. So the approvals at the end of the project became quite fluid and immediate, working with the city to describe the advantages of passive house. And we do have to do things a little differently, and the energy intensities are so low, proving that we have enough power to keep the building comfortable, and proving we have enough power to keep it dry vis-a-vis the humidity in the summer. I'm not going to say it was a challenge, but it was an extra level of conversation, right? Working with Adam very carefully to convince Toronto Community Housing that this was a long-term value add, right? And instead of it being a marketing job, like literally being transparent with the options, and what are the outcomes. And like I'd like to give credit to the engineering team that we worked with at Morrison Hershfield, now Stantec, in developing that optional matrix map to optimize the costs to get to the solutions. So for me, it was, again, being quite transparent about what it meant, because we modeled a code compliant building, we costed a code compliant building, we modeled various increments, TGS and then passive house, and really looked at what the value proposition of that was. So I would move that forward even more intensely now, because I think when you work with a trusted group, they actually want transparent, honest answers, and they're going to make up their mind for the best value of, for example, in this case, Toronto Community Housing and Torontonians. So I thought that I would do that even more earnestly the next time.
Yeah, I think the honesty portion is the lessons learned is a hard is that's an interesting one. I think that maybe I could probably only really answer that earnestly after we get people in there, to be completely frank with you. Because nothing is 100% until it's over. And I think that for me, we had a lot of ideas. We had a lot of discussion, a lot of figuring out how to do things, with an idea of how do we make tenants' lives better. And I just think I still have to be open to that and see. I'm sure there's something that we forgot. I'm sure there's something that we missed. And it wasn't for the lack of trying. But I think just being really honest and being aware of multiple levels of narrative on the building, and being able to understand where we sit vis-a-vis in the building, in the community, in the city, in the region, as part of a corporation that addresses the needs of the most vulnerable people in the city of Toronto, and understanding how to triangulate that into something that makes sense. And then for us, I think it's not just one project. It's how do we take this and port these things into other projects. Maybe the next project is not going to be EnerPHit, because majority of our work is done in occupied residential, but there are so many lessons I think that we can take from this project and port those over so that we can strengthen our portfolio writ large. So yeah, we'll have to see what the tenants do with it. Is kind of
yeah. So that's actually my next question: is when will this be occupied? It's 17 units.
I don't know, Kevin. When? So sorry.
Well, we're expecting substantial performance the end of January. That's to schedule. So there'll be some commissioning after that, and then it's ready for occupancy. I think Toronto Community Housing
2026.
Oh yeah, for sure.
Okay.
Yeah, definitely.
Okay. And how will it be decided who gets to move into these beautiful units?
That's Adam's question.
I hate to I'm going to give you the corporate answer and say not my job. There is a very strong and dedicated tenancy management staff at Toronto Community Housing.
Right.
There is a very judicious process, and I am I stay in my lane on this one, and yeah. So
okay, thank you. Thank you both.
So we have just one more question in the Q&A box. I think we have time for this last one. So this is from Denny Papetti, who says, "Hi, Kevin and Adam. Congrats on this long journey and a great accomplishment. Is the comfort of the unit interiors designed to be consistent throughout all our Canadian 4 seasons? Is there any impact on opening windows throughout the year that may have any impact on how the building operates or performs?"
Yes, Denny, hello. And I would say that we were very careful in looking at the full range of set points, and definitely on the heating side, we have that's well covered and very proven under the Passive House standard. I would say where we start to look just a little more carefully is in the summer, the high humidity. So each unit is demand operated. So if I'm gonna have to look carefully, but the fan coil in the summer has a humidistat. So if somebody opens the window and that humidistat that could trigger the cooling. We have good control strategies, so we can track on the measurement and verification side how the building maintains performance or drifts. But we have humidity control in the summer, which I think is really, really important. So yes, we expect very, very good comfort. And we have the ability to track it to make sure that the building can maintain that level of comfort. That was important. Adam and I talked a lot about passive cooling, and because we couldn't get cross ventilated units because of the double loaded corridor, we emphasize the mechanical dehumidification. So I hope that answers your question, Danny. I'd be happy to take a phone call. I haven't heard from you in a while, and I'd love to
hear from you.
It's nice to have so many friends on the call, so that's
yeah, I love it. Yeah.
That's great. Well, I think that's all the questions in the Q&A for now, unless there's any last ones coming in. But if not, I want to thank you both again, Kevin and Adam, for a really excellent presentation. And I hope that we'll get to follow up with you maybe in a year's time once the building's been occupied and we can sort of see if there's any developments, any changes that need to be made. That would be great to find out as well. See, yeah, no more questions in the chat. Okay, great. So I just have a few closing announcements before we finish off for today. So again, for those who are seeking continuing education hours, please note the OAA will record participation in this webinar on your OAA transcript, so there's no need for any individual reporting on your part. We just kindly ask for some patience at this busy time of year as we process and confirm the accreditation of your hours within the next few weeks. As well, all attendees will soon receive an email with the slide deck from today's presentation and as well a survey for your feedback for our presenters today. So if you get a moment, we really appreciate, and I know our presenters really appreciate receiving that feedback as well. Finally, our next climate action webinar takes place actually in 2 days on Thursday, November 28th, with the title Regenerative Design Framework. And we also have just 3 more webinar offerings left for this year, and they're all climate action offerings as well. So the first is titled AI in Architecture, and that is being offered on November 27th. We have another on December 4th titled Place, Culture, Climate, a Northern Boardwalk Story. And then finally, our last webinar will be on December 11th, and that one is titled Systems Approach for Mass Timber High Rise. So again, these are all climate action webinars. So if you are looking to fulfill your climate action requirement, be sure to check those ones out. So finally, thank you very much again to Kevin and Adam. Thank you to all of our attendees today, and thank you for all of the great questions. And I hope everyone has a great remainder of their day. Thank you.
Thank you.
Thank you.